Bismillahirrahmanirrahim. I think it's 6:30 now, and we are going to start. And we have about 21 people with us, and everybody else is going to join very soon. So before we start, this is going to be our first part of SPSS training, in which we will cover the basic things, starting from the what is questionnaire, how do you code your data in questionnaire, how do you insert your data into SPSS. Then we'll also talk about some basic analysis like demographics, like crosstabs, descriptive statistics, reliability analysis, and correlation. In the second part, that's going to be held on next Friday, we'll talk about the regression, and especially mediation and moderation analysis. So before we start, we need to be clear about a few things about SPSS. Well, this is one of the softwares that we use uh, to analyze our quantitative data. And the abbreviation of SPSS is the Statistical Package for Social Sciences. So that means it is going to analyze data statistically. So if we want to analyze our qualitative data, for example, interviews and other things, this software is not for the qualitative data. This is only for the quantitative data. So statistical package for social sciences. What we'll do is that I'll explain it step by step, and then after I'll complete one step, I can entertain your questions. And obviously, you'll have in order to question, you'll have to write it in the chat box, and then I'll be able to answer it through this live session. So I guess let's start. But before we start, we need to understand a few things. As we talked about, that this will only take your quantitative data. So usually, in the first section, we are asking questions related to gender, and then we are asking about the experience. Then we are asking about the educational level of the respondents, and how many times do you buy a product, we want to ask. And then we have this age. This is the first part. In the second part, we have this scale related thing. For example, if you're using the Likert scale, we give this scale from 1 to 5. And this is a key that you should be mentioning in the beginning of your questionnaire. So people have an idea that whenever they are ticking or encircling the answer, they will be keeping these things in mind. So it is from 1 to 5. 1 is strongly disagree, and 5 is strongly agree. On the other hand, when they go to this portion, this is the first variable that we are trying to measure. And these are the questions that we are using to measure one variable. For example, 1, 2, 3, 4, 5, 6, 7 questions. So in order to measure formalization, we are asking people 7 questions. And then all 7 of them, they have these 5 options, 1 to 5. Obviously, 1 strongly disagree, as we saw it in our key, and 5 is strongly agree. Why I've highlighted them, I'll talk about a little later. Then our second variable, that is creativity. So in order to measure creativity, we are asking some other questions, and they are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 questions. And the same way, we are giving options to all of our respondents to respond according to the key that we've already provided. Then the third variable is the innovation. And in order to measure innovation, we are using these items. And again, the same kind of skills that we are asking from our response. So now, if these are the three variables that we are trying to measure, and these are some of the demographic questions that we are trying to measure, let's say this is our model. For now, this is our model in which obviously formalization is our independent variable. Organizational innovation is the dependent variable. Employee creativity is our mediating variable, and education is our moderating variable. So this is the model that we'll be testing in our training, and we'll talk about how we're going to get our correlations, how we are going to analyze our hypothesis, how we are going to get data. Otherwise, so this will be the basic model that we will be using. So first, if we have understood the questionnaire, then we can move to our SPSS sheet. So any questions related to the questionnaire, I can answer, and then we'll move to our SPSS sheet. I'm waiting for your messages or questions in the chat box. So some people are saying how to download this SPSS. Well, you'll have to put this link that I've just sent, and then you can download it and install it in your computers. So if you're unable to do it right now because it's going to take some time, then what you can do is you can download it afterwards, and you can this recording will be available to you, and then you can obviously do the exercise on your computer. Yes, people are asking that can there be more questions? Yes, there can be any number of questions. As long as you're measuring one variable, there are defined scales, and those scales have different people have developed it, different people have used it. So it is not always that there are fixed number of items. There can be 14 items. There are some variables in which you can go for like 3 items. So it is completely up to the scale that you are using. Okay, how to search for questionnaire of items? At the end of the training, I'll send you some links, and then you can use them, and then you can find your items. There are particular websites through which you can find items. Then there are, for example, if you're reading a paper, and that paper and those authors, they've already created those scales, you can always email those authors and they can also send you those. Otherwise, you can just use Google or Google Scholar to find these items. So it is not that difficult. But at the end, I'll be sharing some links with you. I'll just note it down, and I'll be sharing some links with you. Okay, good. There's another question of reverse items. It's a good question. So sometimes what we do is that when we are trying to measure something, for example, let's take this creativity. The first item that we're using is that I often find myself totally involved in thinking about new ideas. Now, this is a straightforward question, which is actually measuring creativity. So, what if I do these things? What if I say that yes, I am always involved in new ideas? That means I am a very creative person. So, this is a straightforward question. But what if I just put I often do not find myself? So, this do not will obviously change the direction of the question. At the first place, we were trying to measure what is creativity, and if the employee is creative or not. But with this question, we are trying to measure if the employee is not creative. So if you use these terms, do not, will not, so this not term is going to make your item or question a reverse question. So in order to cater that question, what you can do is, if you have these questions in your questionnaire, because first of all, why do we do it? If you can look at this here, this question. This is the question: I do not enjoy problem solving at my workplace. This is against creativity. That is why I've given this R in front of this question, which indicates that it's a reverse question. So how do we treat it? Uh, if somebody is responding one to the reverse question, we have to reverse the code, and one means five, and five means one, two means four, four means two, and three is three. This is how we actually treat our reverse question. Usually we put it in our questionnaire because we want to be clear that people who are filling it, they are not just ticking it without even looking at it. So if somebody is answering to this reverse question as five, which means strongly disagree, and all other questions somewhere here, that means the person has read the question and now he's answering it carefully. So this is why usually we do it. But if you do it, you have to obviously reverse code it. We need to convert 5 into 1 and 1 into 5. Uh, Another question is that if I can send you the link, you can go to the same channel and then you can find how to find items for the questionnaire, and you'll be able to get that link. But otherwise, at the end, I'll be sharing those links with you. So this is all about questionnaire. Now let's move to our SPSS software. SPSS software, it looks like this. And when you open it, it's going to take a little time. Okay, so this is the actually questionnaire that that's going to help us. This is the questionnaire that is going to help us now insert our data into SPSS sheet. Okay, so this is the SPSS sheet. The basics of this sheet starts from its windows. The windows actually, they look like the Excel windows. It's like a worksheet. But the main thing to understand initially is that it has two windows. If you look at this left bottom corner, it is saying data view and it is saying variable view. Data view and variable view. So the moment you click data view, it is going to take you to some other window. The moment you will click this variable view is going to take you to another window. Now, both of these windows are going to be connected at the end, but first we need to be very sure that it has two windows. So the first thing that we need to do here is that we need to set our variable view window. This is the first thing that should entering the data. Before going towards any analysis, you should be having a clear idea about your variable window. So how do we manage this variable window is by looking at this panel. It is saying a lot many things, for example, name, type, width, decimal, label, values, missing, columns, align, measures, and role. For initial learners, we'll only be covering a few things, and then you can find out the usage of the rest of the these headings. So let's start with the name. We'll talk about the width afterwards. Decimal we'll talk about a little after. Label we'll talk about right now, and the values. So the two important things to insert in this variable view are the name and the values. But how do we do it? Now we've already seen our questionnaire. Let's take our questionnaire side by side and see how do we make our variable view. Starting from our very first question, which is gender, what we need to do is we need to have all of these questions, for example, gender, experience, educational level, and then these questions, and then these questions, and then these questions, all should be inserted in this variable view before we're able to put our data into SPSS. Even if you're copying your data from Excel sheet to this variable window and data view window, you will have to create this variable view. So let's start with the gender. I'm taking another question. So it is saying that once we have developed questionnaire, how can we write those questions in the tabular form? Do we need to write separately each question in table, or if there are any techniques? No, you can use any method, any formatting. So what you can do is you can look at this questionnaire, or you can use anything. It doesn't have to be in a table form. It can be in any other form. As long as the respondent can understand what you're saying and then they can answer you, it is completely fine. So it doesn't have any problem. So the gender part. For example, this is our first question, and make sure that you understand that we have two options for it. One is male and the second one is female. In the name window, what we will do is that we will go to our name part, and here we are going to write the gender. For example, I'm giving a space of respondents. For example, if anything I'm writing here like this. The moment I'll click out, it is going to say that variable name contains an illegal character. Now, I did it deliberately. Why? Because in the name section, somehow this software does not allow you to give spaces or use any illegal character, which the computers consider illegal. So what I can do is I can just go for gender, or if I need another word, this thing, then I need to give underscore, and then I can write anything with it. Off, and then instead of space, I'll be giving underscore. So if I do this, now it is fine. It's not creating any problem. But I suggest that you just write the name or the abbreviation of something to understand, uh, just to understand what is this variable or what is this question. Otherwise, you don't need to write the whole thing. Now, suppose if you want to write the whole thing and you say that no, it is the statement is very important, then what you can do is you can use this label area. And in the label area, gender of the respondents or anything you can write. It's not going to give you that problem of illegal characters. For now, I'll just delete it, and we are not using labels, but if you want to use it, you can use the sentence in the label form, but not here. Here, you just need to mention one or two words. In fact, one word is enough. The second important thing is the value, this one. Now, as we've asked the question of gender and we have given two options, male and female, you can go to this value box in front of this question, and the moment you're going to click it, you'll see this blue button here. What you can do is you can just click it and it's going to give you another window. What I did, just value in front of my first question or the question I want to put values for, I'll just go to this value and it is going to give me this window. Now, this window is actually asking me to code my data. As we've already talked about that SPS is only going to take the quantitative data, but here we are measuring something which is qualitative. We need to convert this male and female into some numbers. Either you can go for 0 and 1 or you can go for 1 and 2. You can give it in any order, but they should be in some numeric forms, something in quantitative form. So in the values, I'll write, for example, 1. It is saying that what do you want to label 1 as? So I'm saying 1 is male and add. 2 is female and add. So as in the gender section, I only had 2 options. So this is enough. This is fine. Let's suppose if I made some mistake or I want to change it, you can simply click it, remove it, or just change something here like this, and you can change it. So this is how you can give value to your question. And just click OK and it will save its values. For example, if you go and see it again, it's saying 1 is equal to male, 2 is equal to female. Now, you need to be very careful because when we'll be inserting data, we'll be using these 1 and 2s and not male and females. So let's just go to another question, that is our experience. So experience here, and then obviously in the experience box we have how many options? 4 options. 1 is equal to less than 1 year, add. 2 is equal to 1 to 5 years, add. 3 is equal to 6 to 10 years, add. And 4 is equal to 11 years or above, add. Another question, we'll just do this last one, education, and then we'll give values of education here. For example, intermediate, bachelor's, master's, and MPhil and PhD. Or if you've given more options, you can put more values in here. Now, suppose we have covered our first part, which is the demographic part. Now we need to insert these variables. Now, I think here is a little catch. All of these questions or variables, they had some name, for example, gender, age, experience, etc. But now they have full questions. So what I want you to understand here is that a best method to insert these questions in the SPSS name part is that go with some formula. For example, if you're measuring formalization as a variable, and formalization has 7 items or 7 questions through which you are measuring this variable, I suggest, or you can always go with your own created formula, but the easiest formula can be that what if I consider this first question as F1? But then I need to obviously remember it that F1 is the first question through which we are measuring formalization. So the same way this can be our F2, F3, F4, F5, F6 and F7. So what we'll do is we'll put F1 here. Then suppose, what about the values of F1? So F1 values are here. 1 to 5, 1 to 5. And what do we mean by these values? So go to this value box. 1 is equal to strongly disagree. I'm using these abbreviations you need to write the full names. 2 is equal to disagree. 3 is equal to neutral. 4 is equal to agree. And 5 is equal to strongly agree. Add and OK. So we have added our values here. Then we can go to F2, F3, F4, F5, F6, F7. So as I was measuring my formalization variable with 7 questions, I have given 7 questions. Now, one thing that you can do here is, because all of these questions have the same scale, which means 1 to 5, and the same values as we mentioned above, what you can do is you can just go to this already created values, right click, copy, and then select these and paste. So by copying and pasting, you will be able to cover all of these variables. The same way, for the second variable, employee creativity, I can say that I can take it as EC1, EC2, EC3, EC4, EC5, EC6, and so on till EC11. For example, if we have 11 questions. The same way, what we can do with organizational innovation, I can either go with simply innovation, which is I1, I2, I3, or I can go with OI1, for example, OI1, OI2, OI3, and onwards. For example, if I have OI 10 questions, again, you can simply paste those options here. So this is how you will be creating your variable view. So we'll wait here and we'll see if we have any questions in the variable view. So any question you want to ask, you can write it in the text. Okay, one question that I have right now is that can we combine reverse questions with normal questions? Yes, people do it, and whenever you're going to find different scales that people have developed, you're always going to find reverse questions with normal questions. It is good when you're giving it to people who will really uh, read it and then fill it. But the important thing is that once you get those responses and then you're trying to put them in SPSS in the form of data, you need to be very sure that it should be reverse coded. If it is not reverse coded, that means you are not measuring the right thing. Uh, Reverse coding, as we've already talked about, that if somebody has written 1, you need to write it as 5. So if somebody has ticked 5, you need to write as 1. So that is something that you need to do then. It is when you get those questions. So any other question related to this variable view, or we should move further? I'll wait for 10-20 seconds. Okay. So we are done with our first part, which is the variable view. Now we'll move to the second part of these two windows. So now let's just see that the moment we click this data view is saying the same variables that were created. Now, see here, gender, experience, education, F1 to F7, and then OI 10. In the data view, you will have this gender, experience, education, F1 to F7, and then all the variables that you have just created in your variable view. The here created things are coming here. Now, one other thing that we need to understand here. In the variable view, this numbering 1 onwards is giving us the number of questions that we have asked in our questionnaire, or number of questions or items or things that we are asking from our respondents. But the moment you go to this data view, this numbering 1 onwards is going to tell us the number of questionnaires that people have filled, which means that if data is somewhere here, so 22 people have responded to your questionnaire, or there's a data of 22 respondents in your sheet. It will be more clear when we'll start putting the data. So this is the actually relationship between these two windows. Once you have created the variable view, then you're fine. You don't need to come to this window again and again because it is one-time activity. What you can do is you can save it, and after saving it, this part is done. Now let's just move to our data view. Okay, so in order to go to our data view, we again need to come back to our questionnaire. And suppose that this was the first questionnaire that you received after it has been filled by somebody. First of all, this is going to be empty. If you're using, for example, a hard copy of the questionnaire, this will help you in giving your questionnaires numbers. For example, I've given it 0002. You can write for the first questionnaire, you can write 0001, and then onwards, you can write the name of the or the number of the questionnaires. Now, the second thing that we note here is that suppose that in the gender option, the first respondent has clicked male. That is why I highlighted this. And the same respondent in the experience section has ticked 6 to 10 years, because obviously they'll be clicking one of these options. Educational level, people can fill anything, but this first respondent has filled the master's section. And then if you ask some other questions, people will be filling those other questions. Now, in the formalization, this is how people has responded to your questionnaire. For example, for the first question, the person is saying, I strongly agree. For the second, strongly agree. Third, neutral, agree, agree, strongly agree. So here we have some more options by your respondent, and here are some more options. So you have number of questionnaires, and every respondent must have filled it differently. But we are supposing that this is our first questionnaire that we received. Now, how to insert the data of the first questionnaire into our SPSS sheet is that we will go to our, first we have created our variable view window. We'll go to our data view window, and here, as we can see, a number of questions. Now, look at this gender and what people have filled. And remember what we coded here. you can remember we coded male as 1 and female as 2. So when we'll move to this gender part, this is our first questionnaire that we are going to fill. In the gender part, we will be giving it a code which is 1 for the gender because this person has ticked male. In the experience part, 1, 2, 3. So person has given us answer which is 3. In the next part, the person has clicked 1, 2, 3. Now we'll move to our variable questions. And the first question was answered as 5. The second is answered as 5. Then we have a 3. Then we have a 4, another 4, another 5, and another 5. So this is how people responded to our questionnaire. And if we move further, we have a combination of 5, 5, and here. So this is how we are actually filling our data into our SPSS sheet. For the second questionnaire, let's suppose somebody has said or clicked this part. So if this is the second questionnaire, we will be putting 2 here. And accordingly, whatever data will be there in our questionnaires, we'll be putting that data here. Now, one thing that we usually face here is because nowadays, because of COVID and other things, we are using Google Forms to collect our responses. Even if you've collected your responses from Google Form and you've downloaded that Excel sheet, still you will need to create this variable view first and then make sure that the data that you're copying or pasting here is in correspondence with the variable view. For example, the gender data should be pasted here, experience data should be pasted here, and education data should be pasted here, and the same way, all the rest of the data should be pasted here. So anybody has any question related to coding or putting your data into SPSS or any other question? We'll wait for 30 seconds, and if there are any questions, okay. One thing, we've got a question. We won't be going into the detail of your question because it is how you are actually measuring your data. Another thing, first of all, I'll explain is that here, if you can see that the data is coming in 2 decimal places. So if you want to correct it, what you can do is you can go back to this variable view, and here you can see decimals. So if you just put this decimal to 0 and copy and paste in the rest of them, it will convert your decimals into 0 first of all, and now you can only see 3, 5, and 3 here without any decimals. Secondly, you asked what is the difference between scale, nominal, and ordinal scales. For that, you'll have to go to some book or something, because otherwise, if we'll start discussing here, it's going to take us a lot of time. But what you can do is, based on, for example, this gender is only measuring 2 things, 1 and 2. So it is a different scale. So for this, you can always change its scale. And here you can change its scale to ordinal, for example, or nominal. Or if you're not sure about anything, let's keep it to unknown, or let's just keep it to the scale. And for detailed understanding, I'll share some link with you at the end, or you'll have to read a book. The only difference is that how you are actually trying to measure data. For example, if it is in 5 Likert scale, it is going to be something else. If it is only measuring 1 and 2 categories, then it's going to be something health. But for that, you can change your scales from here. This is what you can use in SPSS. Okay, so we've got another question, that is that how we can go about the negative questions. It is not negative, we should call it a reverse question. Let's suppose uh, this is the reverse question employee creativity. The third question of employee creativity is the reverse question, which is saying, I do not enjoy problem solving at my workplace. Okay, this is a reverse question. Now, the person has ticked 5 in front of this question. 5. Okay, fine. But what is reverse coding? When we'll go to our SPSS sheet, and when we'll go to our EC3 question, which is here, EC3, employee creativity. Now, I should not be putting 5 here. Why? Because I need to reverse code it, which means this 5 is actually 1. So I will treat here as 1. Although the answer is 5. But as my question was reverse, I'll treat this 5 as 1. And let's suppose uh, we have another question in which the answer is, let's suppose this one, 1. If this is 1 answer, we'll convert it to 5. So you just need to reverse code it. Okay, so I don't think we have any more questions. Okay. So I'm just closing down this questionnaire for now, because the rest of the things we are going to do, we'll be using our SPSS sheet, but we'll have to come back to this model when we'll be doing our other analysis. But for a little while, will not be discussing this questionnaire. So let's just go to another sheet which is already filled, and we'll do our analysis from there. Okay, so this is another sheet of the same questionnaire which has already been filled. It is already filled, and a few things. For example, if you see that you have created some extra variables or some other variables which are not required. So if you go here and you try and delete it, I'm pressing the delete button, it is not working. So in order to delete this one row, what you need to do is you need to column or row, you need to go from here. For example, this is the 31st cell, right click it and clear it. If you want to clear more cells, you need to select them from here. Otherwise, from here, it's not going to delete it. So I'm just going to delete or clear all these cells. Once I've cleared them from here, automatically they will be cleared from our data view window. So this is another thing that we must know. Okay, so now we have our filled shield, and we are saying that we have collected all the data. And how do we make sure that we have collected data of how many people looking at this sheet? So what we can do is make sure that you are in the data view window. And in the data view, what you can do is you can scroll down and see the amount of highlighted cells. So it is saying that 250 questionnaires have been filled. The first thing, which might not be the requirement of your thesis, but it is going to give you some very clear idea. That is cleaning of your data. Cleaning of your data means that, for example, while I was typing my data here, or while I was working with this sheet, suppose instead of 3, I have mentioned 33 here, or at some other place, let's say at the uh, here I have given 55 or 555, or here I have given by mistake 25 instead of 2 or 5. So these are the mistakes that I've made, but I have no idea how did I make these mistakes. Now, this is a sample of 250 people. But what if there's a larger sample? You can't go from line to line looking at your typos and looking at the mistake that you've made. So the first thing which I should suggest everybody is to go through this data cleaning process. Now, how we can do that? That is very simple. But before that, we will talk about this window. For initial understanding, we will only be using 2 or 3 of these commands and their subcommands. For example, file is used to open your new file or save the same file or few other things. So this has some usage when you are saving your file and otherwise or opening your file. The most used command is going to be this analyze. Now this has almost everything that we try to measure and try to analyze. So this is the most used command and most used thing in SPSS software. For one of our things, we will be using this transform. So if we say in terms of percentage for initial users, analyze is the command that we'll be using for about 98% of the times. Now, first, just a simple of the analysis. Let's say we want to see that if we've made any mistake or our data is clean or if there's any typo or anything. So what we can do is we can go to this analyze, descriptive statistics, and frequencies. I'm saying that you will not be putting this in your thesis, but this is a very useful thing. So analyze, descriptive, frequencies. Whenever we are going to analyze anything, we will be seeing this kind of window. Now this window says that this is all of our data. On the left hand side, this is all the data that is there and out of which we need to select what data do we want to see. So let's just go back and make some more mistakes. For example, I forgot to put anything here and here. I just forgot to put anything here. So let's go back to analyze, descriptive statistics, frequencies, and just for the sake of data cleaning, select all of these, convert them here. Now, here what we mean is that once they were here and this window was empty, this means we cannot analyze anything because we have not selected anything. So in order to analyze things, you need to select the data from this window and then using this arrow, you can convert it to this window and then you can analyze. And suppose I'm saying that I'll be analyzing the frequencies of all of my data, all of my questions and answers of 250 people. So for now, we'll just click OK. Now, another thing that we need to learn here is that now we have another window. This is the main SPSS sheet But the moment I will perform any analysis, I will look at another window which is known as the output window. So this is where your analysis is being saved or being given. You can save this separate file as an output file, and then you can later use it. This has given us a few tables, a simple tables of all of our data. Now, let's just go to this first part. This first part is saying that your valid responses and your missing values. So in the gender section, we have 249 valid, but one is missing. In the experience part, we are saying 249 are valid, one is missing. That means there is some problem with this data. Now, there is a possibility that people did not fill it. Then it is fine. But if you forgot to fill it, then you need to go back and change it. We'll do that just now. But let's just look at our rest of the data in terms of missing values. As you can see that 0, 0, 0, 0, 0, and till the end we have all valid data and there are no missing values, but we have two missing values which are in gender and in experience. So let's just go back to our sheet and see if we have any missing values in the gender, and in that, yes, we have those missing values. Now we'll go back to our 2018 and 2019 questionnaire and see, for example, if they have given these options. We filled them. Now, again, we are going back to our data, and by one, looking at this value, again, it is saying system missing is 1, which we have corrected. System missing is 1, we have corrected. Now, this is good because it is showing all the options that we've already covered. This is good. This is good. Now, F3. F3 is saying that it has one value, which is 33, another value, which is also 1, but it is saying 555, and these two were not our options. So what we can do is we can write down F3 on a paper and then just look at the rest of the data. If it is fine, 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 another EC2. So I have F3 EC2 in which there is some kind of problem with our data, some typos are there. Now just look at more data and we can see that the rest of our data is fine. So this is just a 1 to 2 minute process, but it's going to give you a very clear idea in which variables you have typos or maybe outliers or something. So I'll go back to my F3 values and I'll see that it has 33, it might be 3. Another problem here is that it is, yes, 55, it might be 5. I'll go to EC2 and EC2 is also saying 25, it might be 2. So this way, all of my data is clean now. I can save it. And I strongly suggest that you do this exercise, because before moving to your data analysis and other parts, this is going to give you some fair idea. Okay, do we have any questions till here? Okay, so meanwhile, I don't think there's any question, but if you have a question, you can always ask me once we'll finish the next step. Okay, so this is the first thing that you can do with SPSS and your data. The next thing that we need to do is we'll be using the same function that we've just used, but this time we are only interested in knowing the sample characteristic of our data, which means what kind of people responded to our question. So I'm just interested in knowing about the gender, the experience, and the education of the people. Now, let's learn another thing. One method of going back to the same thing that we just did is analyze descriptive statistics, frequencies. But if I've already performed one analysis and I want to go back to it, there is a shortcut available here. This thing, this drop down arrow, is a shortcut to all the functions that you've recently performed. So I just go to this shortcut and frequencies. It's going to take me to the same window. So it's going to save me some time. Now, this time I'm not interested in knowing the frequency of all of these things. So what I can do is I can just go to this reset button. This is going to make it a fresh window. And I'm only interested in knowing the gender, education, and experience of the people who have filled the questionnaire. And this will also answer one of the questions that we've got, that how to create output. The moment we will shift them here, now we mean that we only want tables for these three things. Now, there are many other things that SPSS can do for you. For example, if you go to this charts here, it is giving us options of bar charts, pie charts, histograms, and other things. So let's just go to this pie chart, and I'm saying that I want these pie charts to be made for the gender, experience, and age. So pie chart is fine with me, continue. And now we are only going to do analysis of these three things. Now, the moment I will click OK, automatically it is going to generate my output window. So OK, and it is creating that output window. Let's just do it again because we already have some other tables with us. So I'm doing the same thing again. This time we'll have a fresh table. This table is obviously telling us that if there's any missing value or something, but we do not usually use it in our paper or in our thesis. But here, now here is our three tables and their pie charts. Now, how to read these tables is first is of gender. Now, gender here is male 143, female 107, and the total sample size is 250. This is the percentage of the male and female. This is the valid percentage, which is obviously is the same, and this is cumulative percentage. Again, for experience, we have these four options, and we have 32, 72, 80, 66, and 250 total employees or total number of respondents. In the education, again, we have 1, 2, 3, 4 options, and 10, 90, 144. For example, if I just ask you that how many people out of this 250 had bachelor's degree. So can you just guess and see? By this, we'll also get to know that you know how to read these tables. So next, look at these pie charts. It is saying this is the key, that green is for female and blue is for male. Then we have these experiences, 1, 2, 3, 4 categories of people experience wise, 1, 2, 3, 4 category of people education wise. So this can give you a lot of detail about your sample size. Any question till now? Please write your questions. Even if I am not asking you, you can write your questions. Then at the end, I'll be able to answer them. But okay, again, the same question is, do we have to write R in front of our reverse questions? Uh, if you do it, it is good because that way you'll be able to know that these are the reverse questions. But when you're sending it to the respondent, you don't need to write it because that way they might guess it and then they give you responses accordingly. Okay, common method bias. How do we reduce it? Uh, we'll talk about it in the second section. For common method bias, we use Herman's test and some other tests. And by looking at their value, we can get to know that if there's any common method bias or not. So we will definitely cover it in the second part of our training. I'll just write it down and we'll cover it. We'll do that analysis. Okay. So next thing is that what we can do is you can always save this file, output file, or you can just delete it if you're just testing your data. The next thing that can be useful initially is, what if I want to know that in terms of gender, how many people are educated in male category and how many are educated in female category, for example. So for that, you can use another very useful bar is that descriptive statistics, analyze descriptive statistics and cross tabs. Cross tabs are going to give you option of putting your data into rows and columns. And how do we do it? For example, if I'm interested to know that gender wise, what is the education of people? So if I just click OK, it is going to give me this table. Now this table is saying one category at the left side, it is kind of matrix, and the other category is here. So in males, 3 are intermediate, 48 are bachelors, 88 are masters, and 4 are MPhil and PhD. Total, there are 143 males. In the female, there are 7 people who have done their intermediate, 42 have done their bachelor's, 56 have done their master's, and 2 have done their MPhil and PhD. So this is a cross tab that you can use with different other things. For example, let's also take this experience here. So it is going to give us two tables. So this table is explaining the gender-wise education and gender-wise experience of the sample size that we've just taken. So this is also a very useful tab that you can use to analyze your data. Now, this will, these were the simplest of the analysis. The next analysis that we need to use is the reliability analysis. For the reliability analysis, uh, normally what we use is the Cronbach's alpha value. Now, first we'll talk about Cronbach's alpha value, and then we are going to see if okay, so this is the table that we can use to first understand uh, the Cronbach alpha, and then we are going to analyze in our SPSS sheet. Now, why do we measure our reliability? Now, the question is that the questionnaire that we are using to measure our variables, are they valid? Do people understand them? Are they correct? Are the number of items that we were using are right? Are they measuring the same thing that we are trying to measure? So that is the reliability analysis. Are they reliable? For example, if you'll be using the same items at a different context in a different place, will they work? For example, if we talk about uh, scientific scales like foot ruler, measuring tape, thermometer, you can use them anywhere and they will give you the same result because they are reliable. And for that, what we can do is we can use this Cronbach's alpha. Cronbach's alpha is a value that has been given by Cronbach, and the value of Cronbach alpha corresponds to these uh, things of internal consistency. What we are measuring? We are measuring the reliability or internal consistency of the questionnaire. Another thing, if you're using reverse questions and you're not reverse coding them, then you'll have problems here. But let's look at these values. If your Cronbach alpha is less than zero point 0.5, this means the questionnaire or the items that you're using to measure that variable are unacceptable. If your Cronbach alpha is between 5 to zero point 0.5 to 0.6, it is poor. If it is 0.6 to zero point 0.7, it is questionable. If it is 0.7 to zero point 0.8, it is acceptable. But zero point 0.8 to zero point 0.9, it is good. And zero point 0.9 and above, it is excellent. So these are the values that you need to keep in mind before you go towards reliability analysis. And now when we'll perform the reliability analysis, you'll get to know the values and then you'll be able to see that if our scales are right or are they reliable or not. But now there are two options. One option is, in fact, that you must do is that now let's suppose you have collected data from 250 people. And then you apply this analysis and you get to know that it is not reliable. So all of your effort of collected 250 data will be wasted. So what people do is they collect data from 30 to 50 people. Let's take 40 people here. And let's just delete the rest of the data. I'm just deleting the rest of the data for now. And I'm going to perform analysis here of let's take data of 60 instead of 40. So if I'm taking this 50 or 60's data and I'm analyzing my reliability, if something goes wrong, I have time to correct it. I have time to redo my scale. But if I have collected data from everybody, then it's going to be a problem for me to do the whole thing again and again. Which is why I must suggest that you go for a pilot test. Pilot test is that you're doing the same thing but at a small scale. Instead of collecting data from 300, 400 people, you're only collecting data from 30, 40, 50, 60 people, analyzing your scale. And if your scale has any problem, you can correct it and then you can move forward. We'll do the same analysis for our full questionnaire, but for now, we are doing our pilot testing. So let's just go to our SPSS sheet And be very careful. There's one problem that most of us do, that I'm just going to share with you. Now, how do we do reliability analysis? You need to go to this analyze, scale, reliability analysis. Just note it down, analyze, scale, reliability analysis. So once we will click reliability analysis, we will again see the same window, but this time it is saying reliability analysis. Make sure you're in the right window. But be very careful how you're going to do this analysis. Now, listen to this very carefully. To do your reliability analysis, you need to put all of your items of one variable into this window. All of your items of one variable to this window, and by default alpha is already clicked here, and we are going to click OK. Now the output window is saying that your Cronbach alpha is 0.516 and you are measuring it with number of items 7. So 7 items are being considered and alpha is 0.516. Now if we go back to our threshold values, our alpha is somewhere here, which means it is not acceptable, it is poor. So what are the corrective actions? Because we have already got our alpha, which is lower than the acceptable range. So at this point, you can diagnose what is actually wrong with your questionnaire. For that, what we can do is we can go back to our reliability analysis. There is a very good function that you can use. That is, click the statistics and there's this option of scale if item deleted. Now it is technical to understand scale if item deleted, which means that out of those 7 items, if there are any items which are creating problem, we can delete it at this point. So we won't have a problem when we move further. So scale if item deleted, continue, and now again click OK. This time it is obviously going to give us the same value, which is 0.516, but here we have another table which is going to guide us that what are the problems of our items. So please understand it very carefully that these values at the end of the table are saying Cronbach's alpha if item deleted. This means that if we delete formalization item number 1, we will get this much alpha, which means it is improving from 0.516 to 0.591. This means that if we remove this item, first item, it will improve our alpha. This also means that F1 is creating a problem. Maybe people are not understanding it, this question. Maybe this is not a very good fit in this scale. Whatever is the reason, but this item is creating some problem. So what we'll do is we'll go back to our analysis. For now, we will delete this item and then we'll click OK. Now this time it has given us 5.591. But again, it is saying that if you delete this F5, this will further improve your Cronbach alpha's value. So what we can do is we can go back and F5 should be deleted, and now it is coming in 0.622. 0.622, we are here. It is still questionable. This way, if you see that by deleting 1 or 2 items, you can get a cronback alpha value which is above 0.7, then you can use it. The same way, reset, and now we are going to use it with the second variable. All of our items of one variable will be shifted here, and we will see if there's any problem. The alpha is good. The alpha is 0.873. So this is fine. If we'll go back, 0.873. So it is a good scale. So this is fine. We don't need to do anything with it. The next is, again, we'll go and we'll see what is happening to our last variable. 0.788. Again, 0.788. It is acceptable. So this is how you actually measure your reliability, but this reliability was being measured as a pilot test of first 60 respondents. So let's just convert it to our full sample data. And if we have any questions, I'll just take a few questions and then we'll move forward. Okay, there's one question that cronback alpha above 8 is considered doubtful. First of all, it I think you're trying to say 0.8. So there are 4 or 5 authors which talk about these thresholds. Some even say that 0.6 is fine. Some say that in certain situations 0.5, above 0.5 is also fine. So in this way, there are some researchers who are very strict about it. They might say that 0.8 alpha is not fine, but most of the people agree with this table. So there might be slight deviations, but most of the people agree with these threshold values. Another question is that cronback alpha of above 8 to 9 considered a doubtful, reflecting biasness in data collection. You can say that, but the problem is that it should be above 0.7 or 0.8. And the other thing, which you might not be able to understand right now, this is a very, very preliminary analysis. But when we'll go to some advanced analysis of reliability and validity and discriminant validity and other things, this is a good sign, because if you get cronback alpha less than 0.8 or 0.9, let's say if you get cronback alpha of 0.7, which is acceptable, but when you move forward with the same scales, your discriminant validity, your convergent validity, your values of AVE, average variance extracted, or composite reliability, which is CR, they will not come right. If your cronback alpha is less than 0.7, 0.8, then those values are not going to be right. That is why most people correct their data, which means correct their questionnaire and collect their data having above 0.8 cronbacks alpha, because that is going to indicate that the questionnaire is going to be fine. Otherwise, if you're saying it is doubtful, there might be some researchers who say that, and there might be some researchers who say that it is considered doubtful or biased data. For that, you can always run other tests like common method bias and other tests, and you'll get to know your data more when we'll run more analysis. One other question is, what is item? Item is actually the statement or the question that you are using to measure your variable. For example, formalization, if it is being measured by 7 statements or 7 questions, these are known as items, because all of them, item 1, item 2, item 3, item 4, item 7, all of them are combined to form one variable, which is formalization. Normally, formalization is known as a construct, and these are known as its items. So the statements you are asking or the questions that you are asking to measure that variable are known as items. So the first reliability thing that we were trying to analyze was the pilot testing. But this time we have collected all the data. Again, we will need to perform the same function. So let's just quickly perform the same function on one of our variables. So it is saying 0.888 measured with 9 variables. So this is fine. This is a good scale, and the direction of your data collection is fine. So you can use it. So there's no absolutely no problem. If there's any question, or we should move towards our next analysis. Okay, so next analysis that we'll be performing, for that we need to understand our model. Model means that how we have created our relationships. So let's suppose we have created our relationships like this, which means formalization, employee creativity, and organizational innovation. This is our independent variable, this is our mediating variable, this is our dependent variable, and this is our moderator. Now, we have measured these things with 7, 9, 10 items. But in order to analyze them, we need to convert them into one data or one value. That is important. So the next thing that we'll do is we will convert these 7, 6, 9, any number of items into one variable. That is known as computing of variables. Computing of variables. Now, just to make us understand the theoretical portion of what we are going to do now, we need to understand that as formalization has been measured by F1, F2, F3, F4, F5, and F6, F7. Now, these are 7 answers, but we need to convert them into one answer. So technically what we'll be doing is we will be taking average, or you can say mean, of all of these responses from everybody. Now there is a question that how many items are required to measure one variable. I've already answered it, that it depends on the scale. There might be uh, a variable which is measured with 20 items. For example, personality is sometimes measured with 120 items, and then there is a then there is a variable which you can measure with, for example, five items. So it is completely up to the scale that you are using. So there's another question which is saying that what about the mean of each variable used for different tests? Yes, we are going to take the mean of all of these variables. So technically what we'll be doing is we will be taking mean, which means 3 plus 5 plus 5 plus 3 plus 3 plus 5 plus 5 divided by 7 will give us one answer. SPSS has this power that it can do this thing for us. So for that, we need to go to another place, which is transform and compute variables. Transform, compute variable. Once I'll click this compute variable, I'll get to this window. Now, this window, you can say it's a calculator for SPSS. As we use our normal calculators, this is a calculator for SPSS. Now, how do we convert our 7 responses into one response is using this calculator. So the simple method is that first you need to give name to this variable. For example, the first variable is formalization. This is my first variable. I can write the full name or maybe the abbreviation. But again, make sure that you're not using any spaces here because it's not going to take any spaces. The moment I'll try and come out, it is going to say that I'm using spaces. For example, formalization process. So it's not going to allow me, or I need to just give the underscore if it doesn't allow you. But variable name is here. Then the next thing that we can do is we can put a bracket, and in the bracket F1 double click plus F2 plus F3 plus F4 plus F5 plus F6 plus F7. So I'll go out of bracket, division sign, and divided by 7. Now this is what actually is the taking mean or average of all of your responses. So once I'll click OK, it's going to say that I have executed this function and I have converted it into one variable. Now, how we can know that it has been converted or not? We'll go back to our variable view and we will see here that there's another variable that has been created, formalization. And on the data view side, if you go towards the end of this place, it is saying that I have created formalization as a variable. Now, at the back end, what did SPSS do? This 4.14 is a mean of, let's just go to these values. That 4.14 is a mean of these 7 values. The same way it has been created for all of these responses, all of these 250 responses. So it has taken all the responses mean. So this has created our variable, which is made up of 7 items into one single value. We'll do that for our other variables as well. Reset. Now we'll do it in some other method. So you'll get to know the other method as well. We are saying creativity, or we can say employee creativity. Now, the other method is that you can go towards this function group, click all, and here you can see mean. In function all, you can go to this mean. The moment you will click it, it is going to say that you have to take mean of what of the values. So what I'll do is I'll go for EC1, but this time I need to make sure that there is a comma in between my values. So just remove this question mark, comma, comma, another variable, comma, another variable, comma, another variable, comma, another variable, comma. another variable, comma, another variable, comma, another variable, comma, 10 and 11. So I want to take mean of all of these variables, all of these items, E1 to E11. This time, because we've already given it a function of mean, we don't need to go out and divide it by 11 or anything. So it is going to calculate itself. So, okay. Now it is saying that it has created another variable, and you can also see this variable which has been created here, employee creativity. And if we'll go to our this side, it has created variable for us as employee creativity. Do it for the last variable as well. Reset and just use the previous method. You can type these words, but instead of typing, because there are more chances of making mistake while you type, so you can use this click method. I know it's taking time, but still it's going to be useful because you end up making less mistakes. So because now this is it has 9 items, so I'm going to divide it with 9, so we'll be able to take its mean. Okay, and we can see that we have created all of these variables. So formalization, creativity and innovation, and here formalization, creativity and innovation. Now this is an important thing to do when you move towards other analysis, but make sure if you're using some other software like Smart PLS or Warp PLS or MOS, these things might be done in a different way. This is only for SPSS. So till now, if anyone has any question, they can ask me, or otherwise we'll move forward. So I don't think that there are any questions. Still, if you have any questions, you can ask me. So after completing another step, I'll be able to answer that. Now, now we'll be moving towards more complicated analysis, but make sure that you have created these variables, and because the rest of the analysis are done on these variables. So the next thing that we need to analyze is the descriptive statistics. And in the descriptive statistics, mostly we are interested in knowing the mean of the data, the standard deviation of the data, the skewness of the data, and kurtosis of the data. So let's just go and analyze our descriptive statistics. For that, you'll go to Analyze, Descriptive Statistics, and this time descriptives. Not frequencies, but descriptives. Once I'll click this descriptive, I'll see a window. And now the different thing here is that we have created some variables, which are these 3 variables. The rest of the analysis we'll be doing with our computed variables. So let's just shift them here. And in the option section, you can see that there are a few things that are checked and there are a few things that are not checked. So you need to make sure that you have checked the 4 things here. For example, mean is already checked, standard deviation is already checked. If you are interested, you can keep these maximum and minimums, but for now we are not using it. But in order to calculate kurtosis and skewness, you need to check them. They are not checked by default. So we have these four things which are already covered. Then you can continue and then you can click OK. The moment you will click OK, it is going to give you these analysis. First of all, it is saying that N, which is your sample size, that is 250. Your mean for the formalization is 3.33, 3.32. Employee creativity, it is 2.76. And innovation, it is 2.8249. Now, just a question that you can think afterwards. This mean should not be more than 5 or less than 1. If this mean for this kind of questionnaire in which we are using 5-point Likert scale, for this kind of questionnaire in which we are using 5-point Likert scale, this mean should not be more than 5 and should not be less than 1. So you can think about it after reflecting this question. Then you move towards standard deviation, which means that how much data is deviating from its center, from its mean. You can also read about it in some statistics book or somewhere. Now, in the skewness part, you have two things. One is the standard error, but this statistics is the skewness value. And kurtosis means that these are the kurtosis values and these are its standard errors. So most of the times we are only interested in these statistics values of skewness and kurtosis, and we are not interested in the standard errors. So four things you can copy from here is mean, standard deviation, skewness statistics, and kurtosis statistics. Now, there is a lot of disagreement to what should be the value of skewness and kurtosis. But simple understanding is that the value should be closer to 0 of the skewness and of kurtosis. This is the simplest understanding. But how much it can deviate to show if your data is not normal. So I'm just quoting one of the authors. There are many authors and many threshold values. But some people say that skewness should be between -1 to +1 if you want your data to be called as normal data. The skewness value should be from -1 to +1. And kurtosis value should be between -3 and +3. But again, I am saying that this is by maybe one or two authors or some authors. Different authors, different kind of data, maybe thresholds are different. But looking at this data, the values are very close to 0. The kurtosis is a little above 0, but still it is within the range, and we can say that our data is normal. And this is just one of the requirements before moving towards hypothesis testing. So if there are any questions, you can ask me about this descriptive statistics, or we will move towards our correlation analysis. Okay, so I don't think we have any questions here. Now let's just move towards the other analysis, that analysis is known as the correlation analysis. But before we go towards that analysis, let's just understand what is correlation. In correlation, the things that you need to understand is that it shows us the mutual relationship or connection between two or more things. Correlation, which means what happens to one thing if the other thing increases or decreases. For example, what happened to your health when you start smoking? If smoking will increase, health will decrease. If balanced diet will increase, your health will also increase. If your salary, let's say for the sake of argument, if your salary increases, your job satisfaction may also increase. So what happened to one thing if you change the other thing? For example, let's just talk about another example of income and expenses. If your income increases, how does it relate to your expenses? Or when your income increases, how does it relate to your savings? For the clear understanding of interpreting these values, you need to understand two things. First of all, you will get a sign of the value of correlation. You may have a negative sign with it, or you may have a positive sign associated with your value. If there is a negative sign, we mean by increasing one thing, the other thing is decreasing. If this is the relationship, then it is going to give us a negative sign. But if there's a positive relationship, then we will say that one thing is increasing will lead to the increase in the other thing. So negative sign, you can say inversely proportional relationship. Positive sign, you can say directly proportional relationship. So this is the first thing that we need to understand. Now we'll understand another thing. What is the range of correlation? So correlation value will always be between +1 and -1. It can never be more than -1 or less than -2, or in simple language, we cannot see or say that correlation value is 1 point something. If somebody is saying that correlation value is, let's say, 1.25, that means it's not correlation value. It will always be between -1 and +1. Now, on the other hand, it can be anything between +1 and -1, which means it can be -0.99, it can be +0.99, it can be 0.30, it can be -0.30, it can be 0.55 in minus, it can be 0.56 in plus, anything between -1 and +1. So you need to be sure that this is the range of correlation. Okay, now starting from this value, if the value is 0 or sometimes it is closer to 0, we will say that there is no correlation, no relationship exists. But if there is some digit or some value of correlation either in negative or in positive, then we need to interpret it as having different strength. So let's just start from this. If there is one value which is in positive, because obviously you know that if there's no sign, we can say that it's a positive sign. So one digit is saying perfect relationship, and the sign is saying that the relationship is positive. But if it is something closer to 0.75, we will say it is a strong relationship, but at the same time, it is positive, which means increase in one thing will lead to increase in another thing. Then, if you have this -1, it is perfect but negative. The same way, if you have this 0.25 in positive, you're going to say it's weak. But here, it is also weak. The difference is that this week is positive and this week is negative. Now, please understand that weak does not mean that it is not good. It is good. I mean, it is fine. If you get a correlation which is 0.20, it is fine. There's no problem. As long as it is significant. We'll talk about this concept when we'll move towards our analysis. But as long as it is significant, any value is fine. So this is how you actually try and understand your correlation. So let's just, for the sake of further understanding, let's just take these examples. Obviously, smoking and health, for most of us, we'll see a negative correlation. That if one will increase, the other will decrease. Or we can say that balanced diet and health has a positive relationship. This means if one is increasing, the other is also increasing. The same way, let's suppose if it is true, salary and job satisfaction might also have positive correlation. These are just examples. But let's just take a few more moments to understand that income and expense has a correlation of -0.50. This means that when income increases, expenses decreases, although it is not theoretically correct or might not be correct in most of the contexts, but we will have to look at the value. If the value is saying negative, we are going to say there's a negative relationship. And maybe income and saving, they have a positive relationship, which means that if income is increasing, the savings are also increasing. So this is how you will try and understand the correlation, and this is how you'll be interpreting the correlation. So I hope you've understood the concept, because otherwise you won't be able to interpret it. So let's just move to our SPSS sheet. And if there's any question, please you can write it down and I'll be able to answer it the moment I'm done with any of the next steps. Now, in order to calculate your correlations, what you can do is you can go to this analyze, correlate. You'll have to find correlate. And for social science analysis, we use bivariate analysis, bivariate correlation. So analyze, correlate, bivariate. Once you click this one, it's going to give you another window in which Pearson's correlation is already checked, and we are also interested in the Pearson's correlation. There are also other options, Kendall and Spearman correlation, but these are used for non-parametric analysis, which we are not going into detail of those analysis, but for now you can say that you're going to analyze the Pearson's correlation. Just for the sake of understanding, let's just put our variables here. Correlation and OK. Now this is going to give us a matrix. The first thing that we need to do here is to understand how do we read this matrix. Now look at this side: formalization, creativity, innovation. And the same order is here: formalization, creativity, and innovation. So you need to understand this one. It's a matrix. Now, how can we read this matrix? Now, make sure that you can only look at the relationship of two variables in correlation, which means that how formalization is related to, for example, employee creativity or innovation. So this way, this matrix can help us. For example, you can see 1, 1, 1 diagonal here in these results. So formalization with formalization is 1 because obviously it's the same data, it's the same thing. So it is perfectly correlated. Again, employee creativity with employee creativity, in this box it is 1, and innovation with innovation is 1. This is the first thing to note. The second thing is that there is a duplication of data, or you can say the mirror image of the same data. For example, if I want to know the relationship between formalization and, let's say, innovation. So formalization is coming from here, innovation is coming from here. So this is the data, which is saying minus 0.508. But the same value can also be found here, because this is also saying formalization from this end and innovation from this end. Minus 0.508. Minus 0.508. So most of the tables that you see in papers and in thesis, you're going to find these values deleted. 1, 2, 3, or any of the values above this diagonal 1 are deleted. For that matter, you only use data or the results once, usually below the diagonal ones. Now, the second thing, here we can see three things. One is Pearson's correlation, that is on the top. Second is the significance of this correlation that we were just talking a few minutes ago. That is 0.000. We'll just talk about it right now. And then we talked about the N, which is the respondent's size, which is 250. So Pearson's correlation is here, significance is here, and N is here. Now, we were talking about that results should be significant. And if you can see these 2 stars here, 2 stars here, 2 stars here, and here you can see that 2 stars indicating correlation is significant at the level of 0.01 level, two-tailed. Significance, for now, you can read about it further. Significance is actually, how do we define and understand is, significance is showing that what are the chances that these results of Pearson's correlation came by chance. That there is no true relationship, but they just came out by chance. Just for the sake of understanding, you can say that the significance or the probability value, we also call it P or probability value, this should be less. The lesser it is, the better it is. Now, how less? How much less? The threshold for social science researchers is that it should be less than 0.05, or in other words, 5% probability, up to 5% probability is fine in order to say that your results are significant or true. In other words, you can say that 95% you should be confident, which is opposite to this p value, because p value is saying that what are the chances that these results came by chance. So again, the lesser it is, the better it is. If the value is less than 0.05, you're going to say your results are significant. In this case, in all of our cases, the value is 0.000. There might be some digit at the end of some decimal places, but up to 3 digits, it is 0.000. So this is very good. How much can we tolerate? We can tolerate up to 0.05. So this is how you first read your results. Now, the second thing is that how do I know that what is the correlation of two variables? So in order to read about correlation, I need to go from one end, for example, formalization. And suppose if I'm interested in knowing the relationship of formalization with innovation. So formalization from here, innovation from here, or formalization from here, innovation from here. So this is the box. So how do we interpret it? We are saying that the value is minus 0.508, but they are significant. Now this means when you increase formalization, your innovation decreases. When you put, just for this data, when you put too many rules and regulations and formalities for your people does not innovate, and they just work as a routine work. The goal is to follow routine work. So innovation decreases when formalization increases. But on the other hand, what is the relationship between employee creativity and employee innovation? So for that, we will go from here employee creativity and we'll go to this one innovation. So employee creativity and innovation are showing us 0.832, which means it is a strong correlation, which means if employee creativity will increase, organizational innovation will also increase. In other words, if people will come up with more ideas, which is creativity, more innovative products or services can be made. So this is how you actually read your correlation table. So any question till now? For today, we will have it as a last analysis, and then in the next section, which is next Friday, same time, we can have uh, other analysis like regression, simple regression, multiple regression, mediation and moderation, and some other things if you people are interested. So any question you can write in the chat box. Okay, so I don't think there are any more questions. So for today, I think that is enough. And I've already shared the link with you to download the SPSS. You can download it, you can install it, and then you can try out these things. Because otherwise, if you're not going to do them yourself, you will not be able to remember it. Yes, there's a comment that unless we do this along with our thesis, things won't be so clear. Yes, you're right, but for the sake of understanding, you can just, I think, start with just creating your own data and just making some tables or something that's going to make you familiar with your SPSS and with the questionnaire. Or um, you can simply make a question, make a few questions in your questionnaire, like 5, 10 questions, and then just have it filled from your family or from your colleagues, and then just try and insert them and then get to the findings and results. So, just for the sake of learning. Also, I'll be sharing the link with you for next Friday. We'll be circulating the email again, and the video recording of this will be available on the same place, and I'll also share the link with you so you can afterwards, while you're practicing, and if you forget something, you can always look at this training. Thank you very much, everybody. I guess that's the end of today's session, and we'll have another session on. Thank you very much. We'll have another session on next Friday in which we'll cover some other things. Yes, we are getting some more questions like SPSS. For to download SPSS, I've shared the link in this chat. I'll also share the link with you through email, so you can download it and then you can install it. Thank you very much, everybody, and thank you for your wishes and everything. Yes, this is basics, obviously, but the idea is that once you start doing these things, then you'll be able to uh, learn other things, because at MS level you might have to go for some more complex analysis at MBA and MS level and PhD level. So, but the idea is that unless you understand these things, these basic things, you won't be able to understand the complex things. So we need to be very clear that uh, you have a idea about SPSS and data and questionnaire and everything. Yes, some of the people have their projects and they can obviously uh, try it in their class projects, and then obviously you people will also be doing your ISS and thesis, and then you can use the same concepts. So thank you very much, and we'll meet next Friday with some more analysis. But I'll suggest that before that you can try these things so you'll have a better idea, because those analyses are a little tougher. There are more concepts to understand, but hopefully we'll understand all the concepts. So thank you very much, everybody, and see you next Friday.